So let's move to our next sort of tier of coupling. And that's going to be a slightly better set of coupling, but still some problems. And that is medium coupling. So as we get sort of closer and closer to loose coupling, you'll start seeing that maybe some scenarios might actually work for these areas. And maybe we're starting to get into the nitty gritty of, over optimizing our code. And that's sort of a decision that designers have to make is, do they want to spend the extra time, extensively designing things, or is it better just to get the product on the market? A lot of times it's better to get the product on the market. So people might put some of these things in there and hope to fix them later, or just say, it's a problem, but we're going to deal with it anyway. And so just keep that in mind, is that we don't have to be perfect when coding software, and there are different requirements depending on different projects. But anyway, the next level of coupling that we're talking about is medium coupling. And so the first sort of classification or the side of this, that common issue that we have, is this idea of control coupling. So it's when data is passed that influences the internal logic of another module. What this does is it sort of breaks that black box mentality. The module no longer just takes input, does something, and then produces output. Now we have this idea that we have to actually look into the black box to figure out what we need to do. So instead of just being able to input 3, we now have to input flags and controllers and switches so that we're actually controlling the internals of this, which again, it breaks that black box mentality, and it requires every module that we sort of communicate with this to have those switches involved. Now, where does this become a problem? Well, let's say that we have this idea of set data. So we have those getters and setters. We're working good, but instead of B just deciding its own fate, doing its own things, it's waiting for a flag from A. A is telling it how to operate by sending this flag. If you haven't heard of a flag is just true, false, or some other value you send there, and depending on that value, it changes behavior. Flags internally are perfectly fine. However, when we're doing them externally, like over here, we have this problem where now the user needs to know exactly what's going on in this module to control whether true or false should be activated. And this becomes a problem because, again, we could have 1,000 different modules sort of communicating and calling this set data function. What if then we change this around? Instead of true, we maybe just made a little thing. Instead of true, we're going with just T. Instead of false, we're going with just F. So instead of those two, we're going to just sort of change maybe just the semantics, just looking at it, the aesthetics of it, instead of, a real meaningful change. But anyway, that would break every single module because every module is trained. It's now tuned to call that flag. So any changes within here are now going to break every module. And you see that pattern again. We're unable to change one module without breaking a whole bunch of other modules. And that's sort of the arching problem with tightly coupled things, is this idea that if we make one change, we break a whole bunch. So this idea of control coupling is, again, when we're sending flags or control signals to another module to try to control the flow of data or the operations over in that module. This needs to be broken apart in a smarter way so that maybe we have a set data certain type, and then a set data other type, and then a set data different type. I'm saying we have 3 different set datas, and that allows us to, instead of having to put control flags in, we can just call whatever set data we need in that situation. And so instead of this having this sort of weird control module where everything's controlling it, we now have a API, and we're all just calling the API. So if we make changes, we can make smart changes to that API. The next idea is this data structure coupling. And with data structure coupling, what we have is it's when multiple modules share the same data structure. And so data structure is just like this, an array or a linked list or some other sort of structure, way that we keep data together. Now, the problem with this is if we are directly calling from that data structure, what if we want to change the data structure? What if there's something smarter, a better way to implement it? Well, again, going down that line of bad coupling, it's going to break multiple modules. Let's say here we're using array calls. So we're saying, array, let's just say this is array A. So we're saying like A of 5. So we're doing direct calls here, or we'll actually just do it, A of 2 and then 0. Or let's delete, that's a 1. So 0, 1, 2, 3, 4, 4, and 5. And so this is A of 3. Maybe we're setting it equals 6 or something, yada, yada, etc. But the problem with this, the problem that we have whenever we directly call from this array is, what if we want to change this to a linked list? And a linked list looks something like this. Well, the linked list, these calls don't work. So if we change this around, we now suddenly have this problem where all of these break. Every single call like this is now broken. We have to go change a whole bunch of modules. A smarter way of doing this would be to have almost a data controller control class. So instead of calling direct functions into the array, what we would do is we would call a getter and a setter in here, and this would talk to the data structure. That way, whenever we change the data structure around, we just change every getter and setter in here, and these would all work perfectly fine again. So like instead of, this sort of A of 5 where we're making a direct call, we'll say maybe get index, and then we'll pass it a 5. This way, the internal workings of how we get number 5, we don't need to know. We're not calling it directly. Instead, we're actually taking this sort of, we're erasing this dependency, and we're allowing this to control all of that control logic. Therefore, again, if we just swap it out to another data structure into a linked list or some other sort of way of storing information that we've created, we can now just do a quick couple of updates in this controller class, and all of our modules work perfectly good again. So that's data structure coupling. This is a little bit more sort of common. It's not the worst thing in the world because, swapping out data structures isn't something that happens all the time, and we don't usually have a whole bunch of modules talking to the same data structure, but it does happen. And in those situations, we want to think about, instead of maybe directly contacting that data structure, looking to build a control class so we abstract that control out just a little bit. So these are two main ideas of medium coupling. You can see how they're not as bad as the other ones where we're making single changes and breaking thousands of things. However, they can be bad. If we're making small changes in certain areas, in certain very specific ways, we still do break a whole bunch of modules. The next lecture, we're going to be covering the last sort of side of things, which is going to be the loose coupling, things that we're sort of going for, areas that we want to use a little bit of coupling for strategic purposes, but keep it as loose as possible.